Okay, so the chemical formula for potassium permanganate is KMnO4. Let me know when you get your molar mass. Manganese 55. Yeah, so you get it? So, like I said, you can approximate. So I list out all three major components of the molar masses. I rounded potassium to 40. Manganese is like 55, 54, 55, 54.9. So I just kind of round them, and then I'd say, all right, 40 plus 64 is 104, plus 55, 159. So yeah, I'm expecting a number right around 159. That's how you know it's very likely to be correct. Now, how much time should you spend on finding molar masses if you know the chemical formula without writing anything down? 30 seconds max. 30 seconds. Okay, if you write down the formula, then you should be able to get the molar mass within 30 seconds. And now I do have a little hypothesis because I did not run any experiments to prove it, and that is, I think it's faster and more accurate to type your calculator with a single hand than two hands. Okay, because you're not running like a keyboard that you do with texting. You're just looking at numbers. When you have two hands, you actually have to coordinate a little bit more because you'd be like, oh, who types a number, like left hand or right hand? That actually could increase your error rate. All right, now, so here we have a little vocab right here. It's called formula units. Now, formula units is just a way to address any kind of ionic compound because they are not molecules. Molecules are exclusively covalent. So formula units are like the individuals, the name of each individual for ionic compounds. So now, if we are having 4.56 grams, quick question, more than 1 mole or less than 1 mole? Less than 1 mole, okay? Now, based on what I taught you, as I said, you know 10% of any number, right? And feel free to round this to 160 for approximation. So can you approximate the number of moles right here, since we have the mass? 0.04, 0.04, why is it 0.04? Right, a 0.1 mole, it's 16 grams, right? So you can also round this to 4 grams if you want to. So you divide 0.1 into 4 pieces. So this is roughly around 0.025 moles. Okay? All right? Good? All right, now you will see how this approximation skill, it's going to be very, very relevant down the road next semester. Now, of course, we're not going to put down 0.025 on the answer, but we have some idea already. Okay, so now we say, oh, let's go ahead and calculate. Now, I'm going to show you my notation, and I have a little disclaimer right here. My notations that I'm showing you right now will be considered the minimum amount of notations that you will need. The minimum. If you write anything less than what I'm writing, you are on a very dangerous path. I try to trim it down. I'm a lazy person, but if I say I'm writing it, you are writing it too. So, whenever you write down molar mass, you must write down what the molar mass is for. A lot of students, they just put down the mole and the grams and they do not write down the identity, and that's where confusion comes in. What is that molar mass for? They don't know, and then they don't care, and they should care. All right, number one. Number two, a lot of teachers, they just train students to draw the train track. As you see, I do not do the train track for a couple of reasons. Number one, your teacher would just do this, right? My problem is, well, how do you know how long the track is going to be? Because if you draw it too long, then there's a mental pressure. That is, am I done? Should I do more? Or if you write it too short, like this, you might think like you're done, but you're not done. And the other main reason is that I'm heavily against the train track because first, why are we doing train track? And two, I don't think it offers much convenience than writing fractions. Number three, I asked students from other teachers back in the days, I said, do you know that when you do your train track, you are actually multiplying fractions? And they say, oh, I have no idea that those are fractions. They have no idea those are ratios. They were thinking like, oh, it's a method that you just input numbers in and compute, and that's all. And that would have that would have a very long-term and major severe consequence in the future. Okay? And the final one, and that is actually the most important one. When you write fraction, you got to stop at the end of each fraction that you write down and ask yourself, if you stop your calculation right there, what are you finding? And you should know how to answer this question. What are you finding? Well, for the first stop right here, we will be getting number of moles of potassium permanganate. But is that our answer? No. It's not. That's not our answer. Because why? We're asking for the number of individuals. Now we have the number of groups. Great, but we want the number of individuals. And we say, oh, so if you know the number of groups, then you shall know the number of individuals. Because every single group, it consists of that many individuals. And that's how you ensure yourself that you are absolutely on the right track. And when you do your computation, some teachers will say, oh, you multiply all the numbers in the numerator and then divide by the product of the denominator. I am heavily against that approach. Because, number one, again, it does not offer much convenience. And two, you might forget some numbers. What I would suggest is that you take care of one fraction at a time. So first, 4.56 divided by 158.034, and then on your calculator, you do 6.022 times 10 to the 23rd, and then you get your number, and that is 1.73 times 10 to the 22nd, KMNO4, that many individuals. Not mole, because we are not talking about groups anymore, and if you look at the units, the mole, it's canceled as well. Now, one more thing about calculated input. When you input this number right here, the Avogadro's number, please, I do not recommend students using the parentheses 6.022 times 10 to the 23rd, close parenthesis, that kind of input. Instead, I would encourage students to do this. Do you know how to type this on your calculator? Okay, it's right here on a scientific calculator. It is this, 6.022. See the double E right here? Okay, second, and then type this. You get E, 23. That is 6.022 times 10 to 23rd. On a Inspire calculator, it is this letter right here. So 6.022, press that, and then 23, same thing. Okay, and the reason why I suggest this, because it takes the pressure away from you typing in the parentheses. So you can just do a 6 point, well, yeah, if you happen to divide, you can just type this in, and then you don't have to use parentheses. A lot of students, when they happen to divide by 6.022 times 10 to 23rd, they forget to type in the parentheses, and that's how they rack the whole calculation. It's not like they don't know, but they don't know how the calculator reads the input. Okay? Now, so let me just give a little summary right here. It's not difficult, but in this unit, it's all about ratios. There will be a bunch more, some more ratios that we will have to deal with in just a moment. Okay, and now I am very passionate and enthusiastic about this topic because I actually did some research about this topic when I was a beginning teacher in my early career. I read some research papers, and it turns out that there's a skill called metacognition. Cognition, it's about your thinking. Meta, it's above. So what you're doing, it's thinking about your own thinking. When you are doing all these calculations, there must be an active voice in your head conversing with yourself. Oh, what are we doing? How do you know it's correct? And it is like what we said at the very, very beginning. But you are so good with all these computations that you don't really need to think much. But you were thinking. Because you made a decision and say, oh yeah, 2 hours, 30 times 2. But you're so fluent that you know that is the path. But now we are playing with some new ratios. And we say, oh yeah, it's some new stuff, and we need to take care of it carefully. And that requires your work to talk to yourself, explain to yourself. And that's also the reason why my students tend to do a little bit better, at least, than other teacher students. Because I emphasize on the psychological influence, or the way you have to prepare yourself mentally to compute. Okay?